Hello, everyone, and warm welcome to XConf Extra. We are calling this event. For anyone who does not know what XConf is, it's organized by Thoughtworks as a conference by technologists for technologists. And the on site version of this event happened in Barcelona in September. For anyone who could not join that event, we are repeating some of our talks here with a LinkedIn Live format in a webinar series. So you can also feel the XConf vibes that people experienced in person. Few words about myself. My name is Rahul. I'm based in Munich. I'm a tech principal at ThoughtWorks, looking after architecture, modernization, platforms, and cloud. And this talk here that we record today will be available to you on LinkedIn Live itself, but also on our XConf Europe 2024 YouTube channel. For any questions that you have, you can pop them in the comment section on the chat. And once Andreas's talk is finished, we will be going through them in real time towards the end and answering them for you. But for the moment, we are super excited to have Andreas join us on this talk. Uh, Quick intro on Andreas. He's the head of infrastructure at Elia Group, a transmission system operator. And in this talk, we look at how critical of a role this plays in our society as far as digitalization is concerned, as far as energy security is concerned. And of course, we'll dive deeper into some of the tech areas. So, with that, handing over to Andreas. Hope you're as excited as we are for this talk.
Thank you very much, Raul. So, yes, it's a tech talk, but I want to embed it actually into the purpose of the energy transition. And throughout the presentation, I will repeat and will always put it into the context of basically the purpose and the importance of the energy transition, and especially as we as a tech community do have a responsibility, and I'm repeating that, a responsibility to make that happen. I will go through the presentation very much explaining three main aspects, and I would like you to remember these three main aspects throughout the presentation, even if you go down into the tech details. We'll say, as most of you probably do not know, the energy or especially the power system. We'll briefly explain that because that's the whole driver and context for that before going actually into the tech part. Maybe up front, a few words, and we'll conclude on this one in a nice little video at the end. We should not be worried about our Mother Earth or the planet we are living in. Our Earth will survive and will evolve. It has done that for the last millions of years and so on. I'm much more worried about ourselves, that we keep to have this Earth livable for us. Yeah. So remember that one also throughout the presentation. First aspect, and hopefully I, especially during these times and during this week, do not need to explain that, climate change. See the facts and figures coming from NASA on this one, on our temperature rise, which dates back to 1880. But during summer, there was a nice article released on the Nature magazine, which dates actually back 2,000 years. So the temperature rise on our planet is made by us, and we need to take care that this will not continue. Otherwise, this planet will not be livable by us. The planet will survive. The question is, if we will survive. So climate change is definitely the first aspect, and it has a huge relevance for us, what we as a tech community can do about it. First aspect. Second aspect, if you think of a country, to run a country, think of five aspects, five fundamental aspects we need to take care of. First one is power or electricity supply. Second one is heat, respectively cooling. Yeah. Third one is water, fresh water, wastewater. Third one is transport of goods as well as people. Yeah. And last one is about communication, starting really very much from basic communication, telephony systems, and so on and so forth. You need these 5 things to run a country, respectively, the people and the society living in. The last 4 ones are dependent on the first one, which is power. So if power goes down, it's not good. That Mark Ellsberg described, and hopefully you know the book. If not, highly recommended read. If power goes down within a few days, you have a societal collapse, anarchy. So highly recommended to read that book. Why I'm mentioning that? The importance of power, which we take as a commodity, and it's not a commodity going forward. We need to take care that it stays a commodity. Second aspect, importance of power. Climate change, importance of power. Last aspect, the importance of digital infrastructure, in that context. And without digging too much deep, that's the main part of this talk. Just remembering us on the CrowdStrike incidents, and if especially look at Australia, what happens there. Digital infrastructure is an importance or a critical importance from these 5 aspects, and especially the first one going forward. So always remember these 3 aspects, even going down into the details about what we're talking here. As mentioned, I need to explain a little bit the power system in order to understand the relevance of technology here, which I will do in the next few slides. Power system, so electricity. You have power generation at the top, and you have power consumption at the end. And between, you have a transport of power, which in the industry we distinguish between power transmission and distribution. Should not be of high relevance here. Today or in the past, we had a static southbound flow, which means at the top there were nuclear or gas power plants, which are very much steerable power generation. Whenever we need power, we can fire that up or fire that down. At the bottom, we have very much predictable power consumption. Remember this 5 main aspects. The consumption of power was very much predictable. So the flow, and it's a logical flow, electricity, it's a logical flow. It's a very much static and predictable southbound flow. Easy in quotation. With the whole point, always remember these 3 aspects, especially the first one, with decarbonization and electrification, this is changing. So at the top, the power generation is becoming less steerable. With renewables, you cannot tell the sun, to fire up more or to shine the whole day or in the night and so on. So it's less steerable. It's less steerable. On the bottom, you have the electrification of the 5 aspects I just mentioned. So electrification of mobility and heat, you're all aware of that. And in addition to that, the power generation is also coming from the bottom. So talk about prosumers. You have your PV on the roof. You have your EV, your electrical vehicle. Is it part of the mobility system or is it part of the power system? It's just storage on 4 wheels. So this means something, for the transport of power. So it needs to be much more intelligent than it was in the past. So you do have a flexible north, or we're going towards a flexible north and southbound, respectively, and east-west flow on the power transmission, but also on the power distribution level. So general on the power transport. Due to decentralization of power generation, just explained that, and the flexibility in balancing that, power is all about keeping the 50 hertz or 60 hertz at the same level, like a sea level. Yeah, you have a sea, you have inflows of water and outflows of water. The whole point is you need to keep constant the sea level. And what we have here is the inflow and the outflow, yeah, is now very much flexible, but you need to keep the constant sea level. So the flexibility, yeah, is becoming a huge challenge. This means, yeah, this buzzword intelligent grid, the grid really needs to become intelligent, as it needs to manage, yeah, this north and southbound, respectively, east-west flow. In addition to that, due to the change of generation of power, also new functions are going into the power network, yeah, new assets. Think of reactive power, if you're familiar, reactive power, which was taking care of power generation in the past. With renewables, the network needs to take care of that. So besides the flexibility, also new assets, new functions coming into that. So in summary, in industry, we talk about this 3Ds. Decarbonization, yeah, leads to decentralization, which requires digitalization. Or the reverse, yeah, digitalization enables, yeah, decentralization, which enables decarbonization. In addition to that, talking for Europe, Europe is one power grid. We need to take care of a supranational coordination. So it doesn't help if one country is optimizing as we have a European grid. You probably have seen that in the past. Yeah, we had outages in Spain or in Hungary, which could have caused the whole breakdown of the whole European power system. So the point I want to make is, on supranational coordination, Europe is one power grid, which we also always need to keep in mind, and no point in optimizing one country. With that in mind, I'm now going to the next level. What does it mean for digital infrastructure? I'm trying to get here very concrete. I'm working for Elia Group, and Elia Group owns and runs two transmission system operators, the one in Belgium and one of the four in Germany. Concretely, in Belgium, we are delivering power on the voltage level from 380 kV to 44 kV. This is done over 800 locations, which you call substations. Yeah, we'll come to that in a minute, and several thousands of kilometers of power lines. Yeah, that's national critical infrastructure. The same also in Germany. Here we transport power from 380 kV to 220 kV, with currently around 100 locations, substations, and also several thousand of kilometers of power lines. On the German side, we'll probably double this number in the next 10 to 15 years. So that's the topology we are talking about when we come to digital infrastructure. But that's currently the grid topology. If I'm digging now a little bit more deeper on the technologies, on the topology side, grid infrastructure consists of substations and power lines. So if you look into, and that's a schematic picture, it's not the actual one because I cannot share that officially. So if I'm looking into a substation, I do have assets in there, converters, but a lot of other assets to make that power transportation, that power transmission actually happen, not going into the electricity details here. We have the same one also offshore, renewables, wind. Yeah, so you do have also the substations offshore, Baltic Sea and the North Sea. This is currently being run by what you probably know with operational technology. So dedicated appliances, just symbolizing this here with a picture, to run that. This is changing to information technology. So normal IT, what you see here with normal servers in normal data centers and so on and so forth, for several reasons. Which means, in contrast, that these substations need to become data centers. And we're talking here about data centers in the range from 5 to 10 megawatts on a central level, down to a few hundred of kilowatts, in the edges or in the edges of the substations. So you probably know that trend, with buzzword OT-IT convergence, where operational technology is transforming into normal IT, and by that the substations will become digital substations, normal IT infrastructure with applications running there. Second major aspect, remember the intelligence of the grid, is data has gravity. If you look it up on the internet, there's a theory behind it. Data is being generated at the edge. The same applies here. So in order to make something intelligent, you need to have a lot of data and you need to collect a lot of data, which also requires that you need to be able to process data in a distributed or in decentralized and distributed way. This, which means something for an according IT infrastructure, for an according IT, and so on and so forth. So what we will see is a convergence between grid and digital infrastructure, just elaborated here on substations and data centers. So starting from the very bottom of the stack when talking about digital infrastructure, or let's use the word cloud, at the very bottom on the topology. Just explained that with data centers and actually wide area network to change now into IT terms. That's a fundamental problem, let's say, we have to solve, but it's by far not the only one. Because just on this physical level, if you do not have something like a private cloud, a sovereign digital platform, or however you want to call it, that you consider all these locations, all these data centers as one, you will never be able to run applications or even to have one data platform. And again, if you want to make that intelligent, you need to have one data platform. You don't need to explain that here in detail in this tech community and the electricity community. It's much more of a necessary explanation. So sovereign digital platform, so providing technology as a service, or using here the right words in this tech community, building a private cloud, building a sovereign private cloud. That's at the end what we are facing. I use the term sovereignty a lot, and there are a lot of definitions around it. I try to find a simple definition, especially in our context here, what sovereignty actually means. So, and we had that, remember the CrowdStrike incidents. So sovereignty means no politician or executive wants to explain the public that we have to wait for Microsoft or any other hyperscale or public cloud provider to turn the lights back on in the country. As simple as that. Or a little bit more sophisticated, we as a transmission system operator, and the same applies for also the distribution system operator, we need to be in control. We are responsible and accountable to operate the grid and going forward the digital infrastructure, because it's becoming part of the grid. We need to keep control. So we need to have the flexibility to change and evolve on our grid infrastructure, on our tech stack at the end, to evolve or to prevent a lock-in. Be in control does not mean that you stay in control. We do have an ownership for security and business continuity, so we cannot give it to someone else. We cannot go to any provider and just do it for us. It's part of our responsibility to run a country. Remember the first three aspects. Along with that control, flexibility, and ownership becomes responsibility. Here I'm using the term from Mark Andreessen, 2012. You all remember that, which applies to all industries. And also for here, every company will become a software company, and also such a traditional industry like that will become a software company. No way around. For us, open source is of specific role besides the control and flexibility. We are funded by society, so we also need to give back to society. So open source is a central element of what we are doing or need to do here. vertically scaling out. So just on the topology I explained, there is currently no solution or not to really vertically scale out. Yeah, and I'm using here a buzzword edge computing to the purpose and to the need we have here. But also on the other side, what it does not mean, yeah, we cannot develop everything ourselves. Yeah, so an efficient combination and integration, yeah, is as important. So now getting a little bit more into the details of the, or starting getting into the details of the actual tech aspect. So talked about the sovereign digital infrastructure, really on a topology level, data centers WAN, yeah, talking about this sovereign digital platform to have applications run in a distributed, decentralized way, as well as have a according data platform on this decentralized way. What does it mean actually? So it's building actually a true private cloud and not an enterprise cloud. And there's a huge difference between that. It starts very much on an IaaS level. Look at the hyperscalers. Yeah, same applies here. Most important is to take care of infrastructure. So to be able to abstract infrastructure from a data center level up to an API to make infrastructure 100% programmatic in order to be used upper layers. Currently, yeah, there is no single solution out there. No OpenStack will not do it. Mass will not do it. VMware will not do it, and so on. So it's always integration and combination with the sovereignty principles I made at the beginning. Yeah, it's the biggest challenge. 50% of the effort is taken care of IaaS. Also, you do not see it northbound. Yeah, it's 50% of the effort. Second aspect, if you do want to expose technology as a service, at what cloud is or the cloud platform is about, you need to think about the service life cycle. So any technology, if you want to expose it as a service, what is the common service life cycle and so on. I will come to that more detail in a minute. Third aspect, I want to go a little bit more into detail about data technologies. So if you want to enable building a data platform, you need to take care of providing these data technologies. And it's not only relational, NoSQLs, data streaming databases, and so on and so forth, down to machine learning capabilities, yeah, as a service. Last aspect is about the whole software lifecycle. You are building and providing a true private cloud, and you need to take care of the continuous evolution, yeah, of this platform. So taking care of the software lifecycle. So CI/CD very much, yeah, of the platform software is the fourth major aspect. It's by far not the only one. If you think of observability, security, and so on and so forth, but these are the main four building blocks we need to take care of. I will not go into all of them, but starting with IaaS and service lifecycle, and then say something about data technologies, what we are concretely doing in order to solve this challenge I was talking about. So repeating that point, it's about building and providing cloud, not using cloud. So interesting point is when talking to different people, no, Terraform is not the answer. Terraform is using cloud. Yeah, we have to build everything southbound to order to be able to use Terraform and so on and so forth. So starting very much with IaaS, and also here still with pride, you need to segment and need to separation of concerns and so on. Yeah, how you're going to do that. Yeah, so we model and design and also implement on IaaS level our infrastructure according to the concept of regions and availability zones. Due to the time, I will not go more into detail here. Maybe one aspect, the challenge here with this concept is the vertical scale out. The hyperscale have done that very well on horizontal scale out. We have a huge challenge on the vertical scale out. Yeah, you can still use this concept, but they mean something different on with that challenge. So now our actual IaaS stack, so providing infrastructure as a service, main problem, or the core problem which you need to solve, is you need to solve an asynchronous, highly concurrent problem, because you're talking about network, compute, and storage. We're always dependent on each other, and we're doing that very much with this with this stack, which would require an hour to go more into detail, about it. But at the end, you are exposing all of infrastructure with through one single API. Second, on the whole, if you go one level higher, you need to take care of the whole life cycle and platform management. Stepping on this one a little bit deeper, if you consider everything as a service, you need to consider what the mesh of services are. I'm not talking about service mesh, which is a specific aspect on, and it's a mesh of services. So think about if you have IaaS, if you have a Kubernetes service and a data service, they are dependent on each other. And if you expose everything, you need to model that properly. So the mesh of services based on a proper service catalog and service inventory. So the instantiation of services is highly important. By doing that, you break that down in a common service management engine and a common service management framework. Last aspect on the service lifecycle, if I'm before coming into more of the detail, is when you talk about a service, you talk about products. So there's always a consumer and a provider of this one. You need to be clear about who is a provider and the consumer. So for us, providing services, we are providing technology. So we are the service provider to service consumers, which are applications. We're currently not differentiating between service provider and service producer, because you can be the service provider but not necessarily a service producer, and so on. So think of third-party services which run on your platform. This is going then all the marketplace stuff and so on. We're not doing that currently. The application side itself, is also a service provider, which offers application services to service consumers, but the same principle of the service framework. Last aspect which you need to consider is that you consume your own services. So the services we are providing to applications, we are also consuming ourselves. You need to keep that in mind, to model your old service landscape. So coming to the actual common service framework, if you look from the left to the right, simplified, also it doesn't look like, but it is simplified. What is the service life cycle and how do you model that into a common service framework? With the current state of technology, looking here at the service execution environment, having a common service execution environment very much helps you make that happen. Tried that already 20 years ago, where they didn't have things like Kubernetes and so on. This was much more difficult. Nowadays, with the state of technology, you're getting closer to that one. So long story short, what I want to say is that all the steps here, except the actual usage, is common for any service, no matter if it's an IaaS, block storage, or a Postgres database and so on. All the steps left from use the service instance and right are common. The only thing which differentiates is the actual usage of the service. If you are able to manage that one, you build up a common service framework where you are able to provide all technologies as a service and so on. So concretely, we have just launched our MVP on that one. We've implemented that with what we call our service management engine, respectively our platform resource management. Think about if you go on GCP and create a new project and do the things here. This is our implementation of that. And yes, as mentioned, fundamentally, the current state of Kubernetes and the CRD feature with this common execution environment is very much the base to do that. Actually, before that, it was pretty hard to implement something like that. Getting a little bit more concreter, using that common service framework on our current platform, what we have done, we have provided platform services. Currently with the MVP, these data technologies. We're providing them fully as a service with the underlying common service framework. We have done that also for infrastructure services. So building the IaaS stack and providing that in a common service framework in the same way, just as explained, as services. We are not there intentionally to offer that also for applications. Currently, we just offer the managed Kubernetes, but not the whole service framework. This will come in the next releases because, again, application service or platform services follow the same service framework. And last for now, CI/CD services for applications. We haven't in the current stage also not not fully offer that, but very much use parts of it just as shown here. When we go GA in 2 years, all of them will be offered in the common service framework. Going to the next step, so applying that, explain that concretely for data technology services. So having the common service framework, having implemented. So yes, very much we're using Kafka operators within Kubernetes to do that. Yeah, we are offering these technologies as a service and so on. Differentiate now, offering that technology as a service with the product thinking. So if you have a Postgres database and have all of what I just talked, it's not only offering an own dedicated RDBMS, for Postgres, but you need to think beyond that. Maybe not all applications need their own RDBMS. They just need a database, a schema as a service, or just as a table as a service. If you've built that up, it's easy to offer differentiated products or differentiated product portfolio as a service. That's what we're currently doing. We're not only offering Postgres as a service, but only schema as a service or just a table as a service, because application might not only need their own RDBMS. This whole thing, now I'm coming to the next step, is helping you to actually build a data platform. So also we are just providing the underlying cloud platform. Thinking that through, it helps you to build up an actual data platform. So just visualizing here the capabilities. If you do not have that underlying foundation, you will not be able to get build up a consistent data platform in the context what I explained, the problem we need to solve. Because ultimately, now coming to the problem, ultimately what we have to solve, remember the data has gravity, our decentralized infrastructure. What we have to solve is we have a lot of data coming in from the industry protocols, so IEC 6870 and so on and so forth, but smart meter gateways, IoT devices, and so on. The data problem we have to solve is, as for any other industry, this raw data coming in. We need to be able to structure that syntactically, in order to get to an information level, in order to apply semantic structuring, in order to get to a knowledge level, and applying machine learning and predicting, to get to a wisdom, so to do forecasting really in a consistent way. Ultimately, that's the problem we have to solve in the whole context, what I just explained. And yes, we need to have a lot of intake of external data. Think of weather data, for example, in order to provide the data to efficiently steer the grid in an intelligent way. This value levels of data value chain is not specific for us. It's common for any industry. You know that. So concretely, going to next level of concreteness. What we're doing here is the Elia Group Digital Platform, which is a true private cloud for that purpose. We launched our MVP with 22 products this summer. Currently working what we're calling the product market fit with 28 products in order to go GA 2026, which is very much a stabilization release. So our current MVP tech stack, you can see here different logos. We're not developing everything ourselves, for sure not, but we use a lot of open source. Currently on the infrastructure layer, a lot of commercial off the shelf. There are specific aspects which we need to do custom development, but which will we contribute to an open source community, because I think the problem we want to solve is not something unique and others will benefit from it. But as any time, yeah, we need to constantly evolve our tech stack along the sovereignty principles. That's the aspect, stay in control. With all of what I just said, and now trying to close from what I said, yeah, I'm not worried about our planet. It will evolve. I'm very much worried about ourselves, keeping it livable for us, and we as a tech community have a huge responsibility, yeah, to make that happen. But just in closure, Kevin, if you can play the video, yeah, that would be nice.
Some call me nature. Others call me Mother Nature. I've been here for over 4.5 billion years, 22,500 times longer than you. I don't really need people, but people need me. Yes, your future depends on me. When I thrive, you thrive. When I falter, you falter. Or worse. But I've been here for eons. I have fed species greater than you, and I have starved species greater than you. My oceans, my soil, my flowing streams, my forests, they all can take you or leave you. How you choose to live each day, whether you regard or disregard me, doesn't really matter to me, one way or the other. Your actions will determine your fate, not mine. I am nature. I will go on. I am prepared to evolve. Are you?
Very good. Are there any questions?
There are a couple of questions. Before we get to that, just want to thank you again, Andreas. And the video at the end really gets me every time I watch that. Thank you for sharing a lot. Um,
But
Everyone,
it's a nice video, yeah. But really take that serious, yeah. So if you have children, um, and think about the next generations, yeah, take that really serious. And we as a tech community do have a huge responsibility. So it sounds pathetic. It is not. It is very concrete, yeah. So we can make a difference. I really mean that, yeah.
absolutely. And for everyone who joined a bit late, you just heard from Andreas, the head of IT infrastructure at Elia Group. The chat is now open for questions. I'll be taking some of them. Um, I found it very fascinating, Andreas, how you explained to us the role of IT infrastructure in the critical energy infrastructure and thus the energy transition, and especially the building blocks that you walked us through to actually make that happen in terms of a cloud platform. So I'm hoping this gains momentum and more companies, more organizations follow what we are trying to achieve here and learn from each other as well. We have one question in the chat about the roots of the program. How did it all start, and how did you manage the change aspects as you're executing this?
It really very much comes from the. I've been working in the last 28 years in the internet and cloud infrastructure. So joined Elia Group or Transmission Embrace 3-4 years ago, and coming from then, it's very logical. Yeah, so the problem you have, yeah, it's very logical that you start something like that. So, and that's what I also hope to try to bring across. So just the logical things, what you have to do. It is a huge ambition, don't get me wrong. Yeah. And the change aspect to make that happen, especially from where we currently are, is enormous. So it's necessary, but also very ambitious. So not going into the details of the actual challenge of change, and it's not only within our company, it's within the whole industry. And if you take that further, actually for a country, yeah, because national digital infrastructure applies not only for power, but for the other force as well, and you can even increase that to intelligence service and so on. So what is really necessary to run a country, respectively also to run Europe? It's a huge challenge, and not going into details of our current challenge within the company, yeah, thinking about people, thinking about transformation and so on, yeah, don't underestimate it. It's huge and so on. Yeah, so do not want to elaborate on this one because it would take probably too much time. But what normally you associate with a digital transformation, it is enormous.
And I do believe that whatever you presented is only on the surface. There's tons of things you have to manage behind the scenes, not just technologically, but also organizationally, process-wise, etc. So it
Absolutely.
just goes to show the nature of this kind of work.
And this, I'm just talking about IT infrastructure or modern IT infrastructure or private cloud or cloud. Yeah, there is the application side, there is the data side, there is the business side. So people are working according business processes. There's the grid infrastructure side. Yeah, so I just talked about one layer. There are actually four in total. Yeah.
Okay. One question from my side: if you look in the future 2 or 3 years, once we realize a lot of these platform components and once we gain momentum in the digital infrastructure side of things, what will it allow us to do? What does a future look like with digital infrastructure?
Just talking about for the TSO, for the power industry or power network, it's actually pretty simple. Our single goal, highly simplified, is to keep the lights on. Yeah, so that's what our goal every minute, every day is, and this will also be next year and in 10 years. Our main purpose, is to keep the lights on, to have a constant, always reliable supply of at any point in time of power. Yeah, so to answer your question, the answer is actually pretty simple, that we can keep the lights on today, tomorrow, and in the future. It sounds simple, but hopefully I could explain it. It is not that simple, to achieve that with all the dynamics and the flexibility, in the future. Or phrasing it a different way, and also referring what Julia Roberts here explained, we were lazy in the past, just burning fossil fuels and so on to get comfortable and so on. It's not going to be that simple going forward, and that's what we need to take care about.
Indeed. Thank you for sharing. We have another question on how do you ensure data security and compliance in such widely distributed infrastructure?
There is no single answer to that. So first of all, it's critical infrastructure. So most of it is not connected to the internet or to outside and so on and so forth. Yeah. So, but nevertheless, of course, there is exchange. Yeah. So the whole security aspect is a huge one. You need to also combine it with physical security. And data security is a next level. To be straight, a lot of these questions still needs to be answered, because what we are doing here hasn't at that scale done before. So also the security regulations, when it comes to NIS2 and so on and so forth, of course, you can apply that what we're currently doing, but a lot of it hasn't been thought about even in this tool.
And you mentioned the example of CrowdStrike in your talk, which goes to show how important it really is and what the impact can be. So those were the questions I saw in chat. I would like to thank Andreas again for presenting to us. If you want to know more about XConf, listening to more talks, you can check out our website, which we will share with you afterwards. And we hope to see you at another XConf event soon, hopefully in 2025. For more information on Thoughtworks, you can follow us on our LinkedIn page. And for more information on Elia Group, you could, of course, follow their website. Thank you again, Andreas, and handing to you for any final words you want to share with us before we wrap up.
Thank you for having me, and thank you also for the opportunity. I hope I could raise the interest and attract interest in this community. Any help you can provide, more than welcome. Thank you very much.
Thank you, everyone. Take care.